For Lesson 8's homework, we're going to continue our work with our quadratic functions in vertex form. So state the vertex of the following functions, determine if they were concave up or down, and explain. So this first one has left 2 movement and no up or down. So if you just go left 2 on a graph, from the origin, you end up at the point -2, 0. And this is going to be concave up, all right? And the reason is, remember, A, all right, A is really that number in front of the parentheses, okay, is positive. All right, so A is positive. Let me just write it up here again. So f of x equals A, x minus whatever number you're using squared. I think they used h in the lesson, and then plus k. So, all right, so A is positive. That tells us it is concave up. In the middle, there's no left or right movement because there's no parentheses. There's just up 4 movement. So that's going to give us a vertex of 0, 4. Now this is going to be concave down because A is negative. All right, now I know normally we say A is in front of the parentheses, but if there is no parentheses, you just find your x squared term and you look to see if it's positive or negative in front of that. In the last one, we're -5, so we're right 5 and down 1. So if we go right 5 and down 1, that gets us to a vertex of 5, -1. Now we look at the number out in front. I see a +3, so we will be concave up. And again, because A is positive. Okay? Compare the graphs of the functions f of x equals -2 parentheses x plus 3 squared plus 2 and g of x equals 5 parentheses x plus 3 squared plus 2. What do they have in common? What do they have different? So let's look at the numbers out in front first. Okay, so f of x has a -2. So we know f of x is concave down because it's negative. And g of x is concave up. All right. Well, what else do we know? Well, if we think back a couple lessons ago, remember, the bigger the number is out in front, the more narrow it is. So g of x is more narrow than f of x, right? Because 5 is greater than 2. So now let's look at the stuff inside. So they both have an x plus 3 squared and then a plus 2. So what does that mean? That means they have the same vertex of, now they both have, so plus 3 is left 3 and plus 2 is up 2. So they both have the same vertex of -3, 2. So what do they have different? They have different concaves, so one's up, one's down, and one is more narrow than the other. But what do they have in common? They share the same vertex at -3, 2. Right, 2 different equations representing quadratic functions whose graphs have the vertex, and that's supposed to say vertex, at 4.5, -8. So if we write our most simplistic one here, f of x equals, we won't put a number out in front. If we're going positive 4.5, that means we have to go to the right. So we're going right 4.5. So that's x minus 4.5 squared. And then -8 means we're going down 8. So -8. Okay. And then our last piece, if we want to write another one that has that same vertex, we're just going to put whatever number we want out in front. I'm going to put a -2/3, but we're going to keep our x minus 4.5 squared and -8. All right, so again, same vertex, just different shape to the graph based on what number you put out in front. And then the last one, determine the range of the function f of x equals -1/2 parentheses x minus 2.5 squared plus 20.5. So the first thing we want to do is we want to identify our vertex. Well, we are going right 2.5 and we're going up 20.5. So in that case, that would give us a vertex of positive 2.5 and positive 20.5. Okay, so we know that is either a min or a max point. That is going to be a maximum point, because if we look at it here, we have a negative out in front. So this graph is going to have a concave down shape, which means its arrows are going to point down forever. So our range is going to start at negative infinity, and then what's the highest x value we're going to, or excuse me, the highest y value we're going to get? That's going to go all the way up to that maximum in the vertex at 20.5. All right, so because we have a negative out in front, we know it's a maximum point, concave down. So the arrows are going to point down forever. So our range starts at negative infinity and goes up to 20.5 because that's the y part of our vertex.